in the past, okay? Like last year when we were doing circle geometry, we did tangents. This year when we were doing analytical geometry, we found equations of tangents to a circle, right? Now, in paper one, you may be asked to determine the equation of a tangent to a cubic graph or a quadratic graph, right? Now, the basic idea is that you have already done the equation of a straight line, right? The equation of a straight line is of the form y equal to mx plus c, okay? That's the equation of a straight line. A tangent is a straight line. A tangent is a what? Is a straight line. All right? So what you need to know is that in calculus, this m, okay, which in the past you were finding it as m equal to y2 minus y1 over x2 minus x1. That's how you were taught how to find the gradient in grade 9, in grade 10, in grade 11, and in analytical geometry. That's how you're taught to find the gradient. Now, when it comes to calculus now, we don't use this formula anymore, right? We don't use this formula to find gradient. We use the fact that m is equal to f prime of x, which is also equal to dy over dx. Remember, f prime of x, that is the first derivative, it's a gradient. Okay? That gradient is equivalent to m. Okay? The m that you are used to from grade 9. That m is equal to f prime of x. It's also equal to dy over d of x. Yes, it is also equal to the differential operator. The d of x, the capital letter, but I don't want to put that there because that's not very common. The most common notation is the f prime of x and the dy over dx. Okay, so in calculus, you won't calculate the gradient using this method here. That's for analytical geometry. Okay, that's for analytical geometry. In calculus, you use the fact that the gradient is got f prime of x, which is also equivalent to dy over d of x. That's the calculus way. So, once you know how to find the derivative using rules, you should be able to find the gradient of a tangent at a point of contact. Right? So, like here, the gradient of the tangent at this point of contact here is equivalent to the gradient of the graph at that point. I'm going to repeat that. Remember, a tangent only comes into contact with the graph at one point. So, the gradient of the graph at the point of contact with the tangent is equal to the gradient of the tangent. All right, look here. Okay, can I have your attention, please? Remember, when you draw, let me just use a simple example, say, of a cubic graph like that. If you find, say, the gradient at this point here for the cubic graph, let's say it's a positive 2, right? Let's say it's a positive 2. If you draw a tangent, let me use a different color. If you draw a tangent to this point like that, if we ask you what is the gradient of the tangent, if the gradient of the cubic graph is 2 at that point of contact, it means the gradient of the tangent will also be what? 2. Okay, so at the point of contact, the gradient of the tangent is equivalent to the gradient of the graph. That concept, listen, that concept is the same even in analytical geometry when you have a circle. right? There will be what? The gradient at the point of contact between a tangent and a graph is the same. Okay? Then the other thing, you also need to remember that if two lines are parallel, their gradients are what? Equal. If they are perpendicular? Equal. No. You see, if two lines are perpendicular, the product of their gradient will be equal to -1. Right, so let me just refresh you on that, because you still need to know that in paper 1, in calculus, right? So remember this as well. If M1 is equal to M2, if L1 is parallel to L2. Also, M1 times M2 is equal to -1 if L1 is perpendicular to L2. You need to know that not only in paper 2, in analytical geometry, but in calculus as well, you may get a question where you need to know that. All right? Any question there before I carry on? If you copy that later, or because I'll send the PDF. Right? Then the other thing which I need you to be aware is that sometimes you may be required to determine the values of x and y at the point of contact between the tangent and the graph. In that case, all you have to do is equate the gradient to the, or rather you can just calculate the gradient, or if it's given, you substitute it in the equation. Okay, remember you'll be having you have two equations. One, it will be the equation for f of x, which is the cubic graph. Then you may need to find the equation of the tangent. And sometimes you might need to equate the two in order to solve for x and y at the point of contact. I know it sounds a little bit complex, but it's not, right? So you may need to find the point of contact, right? So here, the point where a tangent touches the graph is called the point of contact. By now you should know that. It's also called the point of tangency, right? If the gradient of a tangent to a graph is given, we can determine the x value of the point of contact by equating the derivative of the graph and then substituting that gradient. So all you have to do is find f prime of x, which is equal to what? To m. F prime of x, this f prime of x here, it is the derivative or the first derivative of the cubic function. It will be equal to m, which will be the gradient. Now in this case here, the gradient will be given. So all you have to do is connect your knowledge of the equation of a straight line and its gradient, the first derivative, and the cubic function. Right, don't worry, let me do some examples. Let me do some examples. Right, examples. So let's do some examples. Right, this is your heading. Remember, your heading is finding the equation of the tangent. That's your heading. So just leave a space of about a full page for you to copy down to the notes later. Leave a space of about a full page. Leave a space of a full page first, then we move on to examples. Finding the equation of the tangent. Finding the equation of the tangent to a curve. A. Alright. The first question here, can I have your attention? The first question says, determine the gradient of the tangent to the graph of f of x equal to x squared plus x. Alright, before I do this question, I just want to remind all of you that there is a connection between the graphs that you did in grade 11, especially the quadratic one, and calculus. There is a connection. Okay? So here, A1, f of x is equal to x squared plus x. So here we need to find the gradient of the tangent to the graph. What is the name of this graph here? It's quadratic, or you can call it a parabola. It's the same thing. Okay? Listen, boys and girls, if you see a function with an exponent which is equal to 2, it means it's quadratic. Do you understand? If there is no exponent, there is x there, it's linear. If the exponent is 3, it's cubic. Okay? So the properties of that quadratic function, you did them last year, and they will come back this year. Okay? By the way, they will come back this year. Right? So now this is very simple. Now, if I want to find the gradient of the tangent to that quadratic function, all I have to do is find the derivative. Alright? So f prime of x will be equal to 2x plus 1. You should know how to find the derivative using rules. That's what you should do. This holiday which is coming in, you should be busy doing your calculus. If you forgot, you refresh yourself some of the concepts. Okay? Are you following that? Now check this out. F prime of x is equal to m. You have to know that. Right? You don't have to get confused. Make sure you always remember that. The first derivative of any function is equal to the gradient. That gradient, it will be an expression. But if you substitute a value of x, you get a specific value of the gradient. So here, we need to know what is the gradient where x is what? 1. So all we have to do is, where there is f prime of x, you put that. So I can write this as 2x plus 1 equal to m. Right? Then I'll substitute the x by 1. So you end up getting 2 plus 1. Therefore, m will be equal to 3. And then you are done. Okay? F prime of x is equal to m. So, where there is x there, we put x equal to 1. This m equal to 3, it means f prime of, okay, because this is calculus, I also have to tell you this. This can also be written as f prime of 1, like this. F prime of 1 means the gradient when x is what? It's 1. It's equal to 3. It's the same thing. And this is the most common notation in calculus. In calculus, you don't usually see m in calculus. But as a teacher, I have to connect the what? The two for you to understand. Okay? In calculus, we use f prime. Okay? And function notation. Are you following that? So these two are the same answer. Either if you write your final answer like this, you get full marks. If you write it like that, you get full marks. But the meaning of this is that the first derivative when x is 1 is equal to 3. What this means is the gradient of this quadratic function or quadratic graph at x equal to 1, it's equal to 3. That gradient, which is 3, it's also the gradient of the tangent at that point of contact. What? Don't say never mind, because you're asking. No, 3 is the gradient. They will touch at x equal to 1. X equal to 1 is the point of contact. They don't touch at the gradient. Alright. Any question before I move on to number 2? Alright. Number 2. All right, number 2. All right. All right, number 2. The number 2 says determine the gradient of the tangent to the graph of y equal to 4x minus x cubed. So the function is now y equal to 4x minus x cubed. But here we need to find the gradient where x is minus 1. Okay? What type of a function is that? Cubic. It's cubic. Okay? Now, this is very important for you to know. A cubic function can have 2 tangents. Okay? A cubic function can have 2 tangents. Because of that, for this question here, we are going to get a gradient. Okay? We are going to get a gradient which is going to be one value, but that value can be for 2 points. Okay? So, since our function is given as y, it means dy over dx will be equal to 4, right? By now we should know that it's equal to 4 minus 3x squared, right? That's our what? Our gradient. Now here, I just need to remind you that m is equal to f prime of x. It's also equal to dy over dx. Okay? Be aware of that. This is very important for you to know. That's very important for you to know. Dy over dx is gradient. F prime of x is gradient. M is gradient. Right? So the next thing now is for me to say m. Well, I'm not going to say m. Just allow me to say f prime of minus 1. I'm using function notation because that's the most common notation. This f prime is the same as m. Okay? So m is equal to f prime of minus 1. It's equal to 4 minus 3 times minus 1 squared. And that will give me 4 minus 3. So the answer will be 1. Which means my m, or my first derivative, is going to be a 1 at x equal to minus 1. The gradient is going to be a positive 1. Are you following? Huh? Are you following?
Yes.
One should say m, but I also need to talk about functions. Well, that's the most common one that you will encounter. Hey, boys, can you control yourself, please? Control yourself. I'm saying in calculus, you use that notation. It's better for you to get used to this notation than this one. Either of these two are okay. But the most common one is function notation. Hey, can I have your attention? I'll tell you why later. But the question I need to talk about your homework. Alright, can I have your attention, please? Hey, Azul, if you want to go, you can go. Right? If you want to be here, you need to be here. Alright, let me carry on. All right, another example. Another example. All right, the question says, determine the equation of the tangent to the graph of that, right? That's f of x equal to minus 2x squared plus 5, okay? Parallel to the line y equal to 8x plus 7. Now here we are now connecting knowledge of a linear function and calculus, also functions. So three concepts. You need to know your quadratic function, you need to know your linear function, you also need to know your calculus. So here we need to determine the equation of a tangent to the quadratic function. That tangent is parallel to a line which has got this equation. Okay? Right? So we have to use our knowledge of gradients. Okay? We also need to determine the value of x and y at the point of contact. Okay? So the first thing, let's find the gradient. Right? So F1, I'm referring to the question here. The gradient of the tangent will be the gradient of this line here. Why?
Because it's a straight line.
Why? Okay, the reason is because the tangent and the line are parallel. Therefore, their gradient is what? The same. Hey, can you stop talking and be part of the lesson? A tangent, okay, remember, a line, can I have your attention? A tangent is a line. Do you agree with me on that? A tangent is a straight line. So, if this line y equal to 8x plus 7 is parallel to the tangent, it means their gradients are what? Are equal. Okay? That's the first concept. Then the next thing now, we need to determine the values of x and y because they are not given. The values of x and y at the point of contact are not what? Given. So we use calculus to find them. So what you do is we say f of x. Can you do me a favor and pay attention? Okay, so here our function is f of x equal to minus 2x squared plus 5. That's our function. Right? Remember, the derivative of this is equal to the gradient. Okay? So if I find f prime of x, it will be equal to m. So the derivative here will be minus 4x. The derivative of a constant is 0. The derivative of this is 2 times minus 2, which is minus 4. Subtract 1 from it, you get that. Right? Then you need to remember that m is equal to f prime of x. Therefore, I can say minus 4x is equal to 8. Then you divide both sides, you get x equal to negative 2. So it means at the point of contact, okay, between the tangent and the graph, the value of x at that point of contact is going to be negative 2. But I also need to find the y value at that point. Because I can't find the equation of the tangent without knowing the value of y at the point of contact. Right? So for me to find the value of y, I have to substitute this x value here into the quadratic function. So it becomes f2 is going to be equal to minus 2 times 2 squared plus 5. And this will give me minus 2 times 4 plus 5. And you get minus.
So it's minus 2.
Okay? So the final answer will be negative 3. It means at the point of contact, the value of y is negative 3. So first thing, I found the gradient of the tangent. Then I defined the first derivative of the quadratic function for me to find the x value at the point of contact. Right, just to draw a sketch of what this means. It's like this. If that this cubic function here, it's a grade, sorry, the quadratic function is a grade 10 function. So it looks like this. It's got a y-intercept at 5, so it looks something like that. Right? So we are saying if the gradient is 8, maybe it could be somewhere here. So we have a tangent there. Yeah, like that. So we need to know what is the value of x here. What is the value of y here? So I found the gradient of the tangent, use the first derivative to find the x value at the point of contact. Then the x value that I got here, I then substitute into the quadratic function to get the what? The y value. Once I've done that, I can now determine the equation of the tangent. So on the next page, I have to say y equal to mx plus c. My y, I found it as, my y is -3, okay? My y is -3, right? Please remember, that's a sketch which I drew there, which means it's probably that the point is in the third quadrant, okay? The point is in the third quadrant. So I'll put -3 here. Where there is m there, I'll put what? 8. Where there is x there, I'll put -2. So I need to calculate the y-intercept. Right? So this is going to be -3 equal to -16 plus c. Take the -16, I'll get 13 equal to c. Therefore, the equation will be y equal to 8x minus 13. Sorry, plus 13. Okay, so that will be the equation of the tangent.
Sir, can I please ask a question?
Right? So that will be the equation of that tangent. It's a sketch. It's just a sketch for me to explain. The actual point where the tangent is I need just to explain the concept of a point of contact. Remember, I was not sketching the quadratic value. I didn't sketch the actual one. Okay. All right. Let me carry on to the next question. Right. The next question. All right. The next example, can I have your attention? The next example is F2. Right. The question says, determine the equation of the tangent to the graph of h of x equal to 4 over x squared, perpendicular to the line x plus 8y equal to 12. So in this question, the tangent is perpendicular to that line, okay? Which means we have to use that line to find the gradient of the tangent first. Okay, so we are going to find the gradient of the tangent first. So I need to rewrite this equation in the form y equal to mx plus what? C. I have to rewrite that equation in the form y equal to mx plus c. So this becomes 8y equal to minus x plus 12. Remember the general equation of a straight line, it's y equal to mx plus c. Remember that, right? Do you remember that?
Yes.
Right, then we divide both sides by 8. Once I do that, I'll get y equal to minus 1 over 8x plus 3 over 2. Therefore, my gradient of that line is going to be minus 1 over 8. This is not the gradient of the tangent. It's the gradient of the line which is perpendicular to the tangent. Okay? The gradient of the tangent is going to be, I'll say m1 times m2 equal to minus 1. If I consider this m here as my m1, it means minus 1 over 8 times m2 is going to be minus 1. Which means the final answer here, m2 will be equal to 8. That m2 is the gradient of the tangent. That m2 there, the gradient of the tangent. Right? By now, I know what you are thinking. Remember, I told you that when you are multiplying m1 and m2, one of them must be positive. So if m1 is negative, means m2 must be what? Positive. If m1 is a fraction, means m2 must be an integer, which is positive. Okay? So it will be the reciprocal of this, which will be a positive 8. All right. Then the next thing now, I need to find the first derivative of this function, h of x equal to 4 over x squared. That's where the calculus comes in. Everything I've done here, it's not calculus, it's not grade 12, it's grade 10 way. All right? Then, so our function is given as h of x equal to 4 over x squared. Okay? Now, to find the derivative of that, we need to remove the division line, so it will be h of x equal to 4x to the power of minus 2. Remember that. Remember we did rules, and I told you that before you find the first derivative, you must remove division lines. You must remove division lines. Right? Then now I'm finding h prime of x. It will be exponent times coefficient. That's minus 8x minus 2 minus 1. You get minus 3. All right? Now I found the first derivative. That first derivative, h prime of x, it's equal to m. H prime of x is equal to m. So if I want to find the equation of the tangent, I have to equate this h prime of x to m. And what's m? It's 8. So it means minus 8x cubed minus 8 minus is going to be equal to 8, like that. Okay? Then you divide both sides by minus 8. You get x to the power of minus 3 equal to minus 1. Okay? Are you following that?
Yes.
Now, this is the same as saying 1 over x cubed is equal to minus 1. It's also the same, remember the denominator there, it will be a what? 1. Then we cross multiply. When we do that, we get 1 on the left and minus x cubed on the right. Minus 1 times x cubed is going to be minus x cubed. Right? Then we need to divide both sides by minus 1. So I can write this as minus x cubed equal to 1. Right? Then divide by minus 1. You get x cubed equal to minus 1. The cube root of minus 1 is a 1. So x is going to be, sorry, the cube root of minus 1 is going to be a negative 1. So x is going to be minus 1. Right? Whatever problems you are having with understanding what I'm doing there, it's not grade 12. Okay? It's exponents solving equations. That's why I said I'm going to talk about that next week. Okay? Now that I found the value of x, I need the value of y. To find the value of y, I have to substitute that x value here. Put the x here. Okay? So I'm going to do that on the next page. So h1 will be equal to 4 times minus 1 raised to the power of minus 2. Alright. What's the answer? What is minus 1 to the power of minus 2? The answer is a 4. Look here. If minus 1 is the base and the exponent, it's a negative exponent, you get an answer which is equal to 1. That is if the exponent is a negative exponent which is an even number. If it was an odd number, then you get negative 4 as the answer. Okay? So y equal to mx plus c. My y is 4. I got it there. My m is 8. Am I right? Yes. Then the x, we got it as negative 1. So you get 4 equal to minus 8 plus c. Then you get 12 equal to c. Therefore, the equation of the tangent is going to be y equal to 8x plus 12.
So that's right. So the equation is negative 1.
Thank you. All right. Now that I have spoken about finding the equation of a tangent, let's go back to the homework before we take the break. Okay, let's go to the homework before we take the break.